Hello everyone, welcome back to my channel Study with me. Today I'm going to explain about Chemistry Standard Level Paper 2, last year November 2023. As usual, if you find this helpful for you, don't forget to subscribe and let's get started. Okay, for question number 1, methanoic acid is the first member of the homologous series of carboxylic acids. Methanoic acid contains OH, so it's a carboxylic acid. So the term of homologous series means they have the same functional group or they have the same general formula. Same general formula or same functional group. Okay, you can answer one of these two because it's only 1 mark. B. Draw the Lewis structure of methanoic acid, HCOOH. So C will be double bond with O, and O, H, and will be C. So O has 2 lone pair, and this O also has 2 lone pairs. Calculate the percentage by mass of oxygen in methanoic acid. So we need to first calculate molar mass of methanoic acid. If you refer to the data booklet or the periodic table, you will find the relative atomic mass for carbon is 12, and as we have 2H, so 2 times 1.01 plus 2 times 16 because we have 2O, so the total will be 46.03. For the percentage of oxygen, we need to divide the molar mass of oxygen, which is 32 because we have 2 oxygen, divided by the molar mass of methanoic acid, which is 46.03 times 100 because it's percentage. So it will be 69.52%. Okay, for D, methanoic acid and ethanol both contain a carbonyl group and have similar molar mass. So when talking about carbonyl group, it's C double bond O. Explain why in terms of the strongest intermolecular forces between the molecules, ethanol has a much lower boiling point than methanoic acid. So before we answer this question, let's see the structure of ethanol is CH3, C double bond O and H. For methanoic acid will be OH. So this is methanoic acid and this one is ethanol. The difference between these two is that methanoic acid has hydrogen bond. So therefore, to answer this question, strongest intermolecular forces in methanoic acid, as it has hydrogen bond and dipole-dipole force for ethanol, because we need to talk based on the intermolecular forces. So intermolecular forces, you have hydrogen bond, dipole-dipole, and London force. So ethanol contains dipole-dipole force. And the second one, hydrogen bond, is stronger than dipole force. So methanoic acid has higher boiling point because it mentioned about boiling point. So you need to have these two reasons to get 2 marks. Outline why ethanol and methanoic acid are both fully miscible with water. Miscible means homogeneous. So if you see the structure for both, they have the ability to form hydrogen bond when it is dissolved in the water. So this H will be able to form hydrogen bond, and then this one, of course, methanoic acid has hydrogen bond. So the reason will be the structure, both ethanol and methanoic acid can form hydrogen bond with water. Predict, giving an explanation, the relative electrical conductivity of solutions of methanoic acid, ethanol, and hydrochloric acid of the same concentrations. Okay, methanoic acid, ethanol, and hydrochloric acid, when we talk about the ability to conduct the electricity, we are talking about the amount of ions. So even though they have the same concentrations, but we need to compare which one has more dissociation, or the ions can be dissociated fully, partially, or undissociated. And as you guys know, methanoic acid has OH. And as you guys know, methanoic acid is an acid, and hydrochloric acid is a very strong acid, and ethanol is not acidic. Therefore, ethanol, it's lower compared to methanoic acid, and this one will be hydrochloric acid. So the explanation here, you can just write conductivity depend on the amount of ions. HCl is a strong acid, so is fully dissociate, and then methanoic acid is a partially, so weak acid is so partially dissociate, and ethanol is not acidic, so is undissociated. Methanoic acid can be produced by the hydrogenation of carbon dioxide according to the equilibrium. Why this process has been extensively investigated in recent years? Of course, because CO2 is a major contribution to climate change. And the other reason is CO2 is a greenhouse gases. State the equilibrium constant expression for this reaction. So Kc, it will be the concentration of the product divided by concentration of reactant. So this will be HCOOH divided by CO2 and then H2 There is no exponential here because the coefficient is all 1. All the coefficients are 1. So this will be the constant expression for the reaction. Okay, for the next question, bond enthalpies are a useful way of finding approximate enthalpy changes for reaction. To determine the enthalpy change, you need to use section 11 of the data booklet, which is the average bond enthalpies. So let's refer back to the reaction is CO2 plus H2 producing HCOOH. So let me write it back down here. All right, so let's break down this reaction. So CO2, C double bond O plus HH and HCOOH. So you have CH plus C double bond O plus CO plus OH. As we have on the right side C double bond O, so on the left side there's one C double bond O, so we can eliminate them. So for C double bond O, if we refer everything to this section, you will get this number C double bond O is 804. So I will just write it here. So 804 and HH will be 436. This one will be 414 and 358 and 460. So the total will be 1240 and this one will be 1235. So these are bond breaking and these bond forming. So to calculate the enthalpy change, it will be sum of the bond breaking minus bond forming. So let's plot into this equation. So it will be plus 5 kilojoule per mole. Okay, assuming a 0.1% uncertainty for each bond enthalpy, determine the resultant percentage uncertainty of the calculated enthalpy change of the reaction. The resultant percentage uncertainty, we can refer to the uncertainty associated with the calculated value. So we have 5 calculated value here. So specifically is associated with the calculated enthalpy change that is involved in the reaction. So because of 0.1%, so it will be 0.001. So sum of absolute uncertainty, it will be 0.804 because 0.001, all right, plus 0.436 plus 0.358 plus 0.463, it will be 2.475. So to calculate percentage uncertainty, so you can just do this calculation divided by 5 because it's 5. I forget one more, 0.414 coming from this. So you will get times 100, you will get 49.5% or 50%. Deduce how the value of Kc would be affected by increases in temperature. So if, for example, the reaction A plus B produce C plus D, as the temperature increases, so delta H will be negative, so this way will be exothermic and this will be endothermic. So how the Kc would be affected by increases in temperature, it will shift to the left because it needs to take in heat and minimize the effect of change. So if Kc increases, causing the position of equilibrium to be shifted to the left, as it needs to take in heat and to minimize the effect of change. The conversion of carbon dioxide to methanoic acid is usually carried out over an iridium-based catalyst. So you need to write the sketch. You need to sketch the diagram, provided energy profiles of the reaction both with and without a catalyst, indicating delta H and the activation energy. So you know this would be reactant and this will be product. So we need this much for the activation energy without catalyst. So this will be activation energy, and if without catalyst, sure, it will be less. So you just need to make it a little bit beautiful here. So this will be activation energy with a catalyst, and this will be the difference of enthalpy, or delta H. All right. State 1 change, other than carrying out the reaction over a catalyst at high temperature, that will increase the reaction rate. Increase pressure. Determine the oxidation state of carbon in methanoic acid. It is a methanoic acid. Should be 0. H is +1, O is -2, O also is -2, so the problem will be here. So to be equal to 0, C will have +2. All right, so when you write the oxidation state, you should write +2. If it's 2 or 2+, you will get wrong. So be careful when you write oxidation state. It should be +2, not 2+ or 2 only. Methanoic acid can be converted into methyl methanoate. State the name of the reagent and catalyst required. So methyl methanoate is an ester. So to make ester, you need alcohol and carboxylic acid to make ester, and producing water using concentrated H2SO4 and heat. Therefore, the answer here will be methanol, because it's methanoate, and the catalyst will be concentrated sulfuric acid. So 1.72 of methyl methanoate is produced from 2.83 gram of methanoic acid and excess of the other reagent. Determine the percentage yield. So 1.72, it's an actual amount. To calculate percentage yield, you need actual yield divided by theoretical yield times 100. So the mole of methanoic acid will be 2.83 divided by 46.03 molecular mass of methanoic acid, which is 0.0615 mole. And for mole of methyl methanoate, it will be 1.72 divided by 60.06, producing 0.0286 mole. Then you just need to plot into this formula, which is 0.0286 divided by 0.0615 times 100, and you will get 46.5%. The conversion of methanoic acid to methylmethanoate can be followed by changes in spectra. State one similarity and one difference you would expect in the IR spectra of methanoic acid and methylmethanoate in the region of 1500 to 3500, referring to section 26. So these are the section 26. So when we draw the structure of methanoic acid and the structure of methyl methanoate, we find the similarities that both of them has C double bond O. So absorption C double bond O at 1700 to 1750. Or you can also see they both has CH and then CH. So absorption CH at 2850 to 3090. So you can choose either one. Okay. And what about the difference? Methanoic acid has absorption of OH. OH at 2500 to 3000, which is absent for methyl methanoate. Did you use referring to the integration trace whether the NMR spectrum shown in that of methanoic acid or methylmethanoate? So I couldn't find the question here, the picture, so I'm sorry, I cannot explain for this specific number. State the class of compounds to which methylmethanoate belongs. Methylmethanoate belongs to esters. Draw the full structural formula of the carboxylic acid isomer of methylmethanoate. So carboxylic acid isomer of methylmethanoate. So we can draw the structure of methylmethanoate as an isomer of carboxylic acid. Okay, so this will be methyl and this will be methanoate. So state the name of a compound that produced the isomer in E in E when reflux with acidified potassium dichromate. Acidified potassium dichromate is a reagent that used to do an oxidation. So when its primary alcohol is oxidized, it will produce aldehyde and also will produce carboxylic acid. So the name of the compound that produced this isomer, that produced this carboxylic acid, will be ethanol. Okay, so the structure will be like this. Carbon disulfide CS2 undergoes gas phase hydrolysis according to the overall equation. Calculate the enthalpy change in this reaction from section 12 of the data booklet and the given values. So when you refer to this section 12, okay, so you will get the number for delta HF. All right, so based on that section, CS2 is provided, H2S is provided, and water, steam, will be negative 241.8 kilojoule per mole, and for CO2 will be 393.5 kilojoule per mole. So to calculate delta HF, it will be sum of the delta HF product minus reactant. So we can just plot here. The product will be H2S and CO2. So for CO2, negative 393.5 plus 2, the coefficient H2S, negative 20.6 minus for reactant, so CS2, 86, so plus 88.7 plus again 2 for H2O, negative 241.8. So you will get negative 434.7 minus, again minus 394.9, and you will get negative 39.8 kilojoule per mole. Deduce the molecular geometries of CS2 and H2S and the reason why they are different. So the Lewis structure of CS2 will be like this, double bond, and then H2S will be like this. So this definitely linear, and this is bent or V shape. Be careful, this is not trigonal planar because it has a lone pair. So the difference is H2S has two lone pairs. Sulfur has a number of natural isotopes, and the samples of sulfur was enriched in 3616X to produce a mixture with the following composition. So calculate the relative atomic mass of this enriched sample correct to 2 decimal places. Usually you guys will divide it by 100, so I would just make it more easier for you instead of dividing it and multiply, for example, 90 times 32 plus 1 times 33 and blah blah, and then divide it by 100. So I would just make it simple by 0.92 is already divided by 100 times 32 plus 0.01 times 33 plus 0.04 times 34 plus 0.05 times 36. So you will get 32.29, the relative atomic mass for S. State the technique by which the percentage of different isotopes in this sample could have been determined. Of course, mass spectrometry. In naturally occurring sulfur, the relative abundance of 36,6 S is only 0.01%. Calculate the number of atoms of this isotope that will be present in 1 gram of natural sulfur. So to calculate the amount of the atom, we need mole. And to calculate the mole, we need the amount of the relative abundance of 3616 sulfur first. So the amount of 3616 sulfur in 1 gram would be relative abundance divided by 100 times mass of sulfur, which is 0.01 divided by 100 times 1 gram will produce 10 to the power negative 4. So now the mole of this sulfur, 3616 sulfur, will be the amount of this sulfur divided by molecular mass of 3216 sulfur, which is 10 to the power negative 4 divided by 32.07 molecular mass of sulfur, producing 3.12 times 10 to the power negative 6 mole. So to calculate number of atom, we need to multiply with the Avogadro's number. So number of atom will be 3.12 times 10 to the power negative 6 times 6.022 times 10 to the power 23. Then you will get 1.88 times 10 to the power 18 atoms. Beryllium is a low-density metal that is used in specialized lightweight alloys. The production of beryllium is illustrated in the diagram. Outline why molten BeCl2 is considered an electrolyte. Molten. Molten means contains free moving ion because it's not solid. And identify the electrode at which beryllium will be produced and the polarity that electrode. Okay, so the beryllium BeCl2, so beryllium is Be2 plus and Cl minus, and for the electrode, beryllium will be in the, my key here is panic, so positive anode, negative cathode. So beryllium is a positive ion, will attract to the negative cathode, negative electrode. So negative electrode is the cathode. Okay, polarity is negative because cathode is negative. Write a balance equation for the reaction occurring at the other electrode to the one you identify in 5A2. Okay, so the other one, the other electrode will be anode. So based on this panic, okay, So positive anode. So anode is positive, will attract the negative ion. So it will be Cl. And the other one, I have the key here, is cathode and anox. So anode will experience oxidation. Oxidation is losing an electron. So when losing the electron will be right here. So definitely electron will be balanced if we put Cl minus right here. So because it's Cl2. So to check whether this is correct or no, so there are two -2 here. So electron should be 2 right here. So Cl2 is a free element, so it's 0. So this -2 and this one also -2. So they are balanced. Explained in terms of nuclear charge, electron subshells and the shieldings provided by filled electron shells. Why the first ionization energy increases from Li to Be but decreases from Be to B? Let's see the periodic table. So the question here, why the first ionization energy increases from Li to Be but decreases from Be to B? So it's a bit odd, right? Because the nuclear charges increases, so the first ionization energy from Be to B should increase, but why decrease? So before you answer the question, we need to divide by 2. Why from Li to Be? Why from Be to B? So from Li to Be, increase in nuclear charge, and Li and B have the same shielding. Shielding refers to the phenomenon where the presence of inner electrons in an atom partially blocks the attractive force between positively charged nucleus and the outer electrons. Okay, so now from Be to B. So from Be to B, electron in B lost from P subshell, while electron in Be lost from S subshell. This is about the electron configuration. So when you write the electron configuration of B, you will reach to the P orbital, but for Be you only reach for the S orbital. So to lose the electron from P subshells is easier compared to S subshell. That's why the first ionization energy from Be to B decreases. And the other reason, greater shielding experiencing by B. This blocking effect reduces the effective nuclear charge experienced by the outer electron, so making them less tightly held by nucleus. So the electrons in Be has the shieldings doesn't really held the electrons, so therefore the electron is easier to be removed. So that's why the first ionization energy from Be to B decreases. All right, so that's it for the chemistry paper 2 higher level last year 2023 explain. I hope it's very helpful for you. So then if you find this helpful, don't forget to subscribe to my channel because I will also do other past year papers. And bye for now.